right. Okay. So today we have our own Curran. Talk about data visualization. So for people from Carnegie, he doesn't know him. He just joined us recently from the University of Massachusetts.
Yep.
He got a PhD in working on data visualization. So he has already built a framework called Model.ts. And I guess he's a new, I don't know if it's a new open source project or is it combined with that project. Essentially got an open source project and that has the data visualization in it, and then the help is going to use it. So with that.
Great. And how long do I have? Like an hour?
An hour.
An hour? All right. So hi everyone, I'm Curran. I'll be talking about constructing interactive visualizations. So the focus of this is on 2D visualizations using D3.js. So if you don't know about D3, it's this really great JavaScript library for making interactive visualizations. And there's tons and tons of it. And so what people do typically when they use D3 is they try to find one of these examples that sort of works for them. Like they want to create a visualization like that. And then they copy and paste the code and then change the code that loads in the data to load in their data instead. And then just use it, which is not really ideal. Like, in my view, a lot of these visualization types should be encapsulated as reusable modules. So you don't have to copy and paste this example code that's hard-coded to one particular screen size and one particular data set. You can sort of take these reusable modules and use them. So what I'm trying to do is provide a path to take any of these D3 examples and go through some process and then in the end have a reusable module that you can sort of plug into your system. And it can interact with other reusable visualization modules. So that's the idea. So the focus is on D3, but you could also use other web technologies, anything that fits in a div, really. So Leaflet is a good example. Like Leaflet has really nice choropleth maps with zooming, for example. D3, doesn't really have exactly all this stuff. So yeah, the core concept of this is data dependency graphs. So this is from this library I made called Model.js. And this is part of my PhD work at University of Massachusetts. So the idea with data dependency graphs is instead of having your program linearly specify like the steps that are going to happen to build up a visualization or a state of a program, you only specify the edges between model properties. So when I say model, I'm talking about a model as like key value pairs. So Backbone is a very similar library to what I'm sort of doing. So here's a simple example of a person model. A person has a first name and a last name. And say you have some web interface where you want to say their full name, like first name plus last name, somewhere on the page. And maybe there's a form for the first name and a form field for the last name. And whenever either one of them changes, you want the full name to be computed. So this is sort of the syntax for using this library. This is JavaScript. So you specify an array of strings, so an array of properties of the model that you depend on as input, and then it uses this kind of dependency injection-like syntax to give you the values, and then you can compute some new value from those old values. And I've come up with this visual representation of this with a lambda here as a function, a reactive function. So this draws from the idea of functional reactive programming, so that's kind of a whole research field unto itself. But the idea is you construct programs by specifying these functions that react whenever their input values change. And then there's some system that automatically manages the updates, the flow of the updates through the system. So, and you can chain these things like, so whenever X changes, update Y, and then whenever Y changes, update Z. And the system will automatically manage the changes. So if you just change X, the system will automatically invoke these functions and propagate the change through the graph. So the whole point of this, though, is to build data visualizations. So here's what a reactive flow looks like for a bar chart with D3. So the idea is there's the container, the page layout, which is in the browser. So let's say you have a div where the size of it is controlled by CSS, and you resize the page, and then CSS sort of runs, and then you get a new size for the div. You'd like to propagate that size through to the visualization when you resize the page, for example. So that would change the size property in the model, and then that would kind of bubble through this function, which uses the size and the margin to compute the inner rectangle size for the visualization. And then that would bubble through this other reactive function that takes into account the input data and the fields that are being used and re-renders the bars. So the idea is this is a nice way to structure reactive visualizations. So rather than having one huge chunk of code that has all the D3 logic in it, the bar chart is implemented in these separate independent functions. So like 1, 2, 3, 4, 5, 6 functions that are independent from one another in terms of like writing the function itself. And then the system manages the updates, how the updates sort of percolate through the system. So if I run this bar chart example, so there's a main program that loads this bar chart module and then periodically changes the input values, and you can just see it reactively update.
It's more like an event-driven model. Some event happens that propagates through the whole system.
Right.
By those functions.
Exactly. Yeah. So I mean, when you get, like, for example, a user interface event, you just set a property on the model, and then once you set the property, then the system sort of takes off. So the system doesn't really work with events in the traditional sense. It works with changing values. So whenever a value changes, it triggers these reactive functions to run. And then if one of those reactive functions changes another value, then all of the reactive functions that depend on that value are then queued to be invoked on the next tick of the JavaScript event loop. So it's all asynchronous too. So it won't like lock your cursor, for example.
So what happens if you do end up having a loop in your vendors, or do you just have to be smart about it?
You just have to be smart. Like you could code a program that has an infinite loop and it would just run infinitely, but it wouldn't block because each step would be asynchronous.
But you could use that to program some kind of like video motion?
Yes, yeah, you could have a feedback loop where you could do, I don't know, some kind of animation or something. Yeah, particle simulation.
I don't practice my code. You have multiple data point changes happening in parallel, or asynchronous.
So the way I've done it with like data points, like let's say you add one record to the array of data points that you want to visualize, that just updates this data property here. So I'm not accounting for that fine level of granularity of like adding just one data point. So it's sort of setting that value to the whole table whenever you update the data values. Is that what you were asking about?
So when that happens asynchronously from multiple, let's say making AJAX calls and data come in asynchronously from different endpoints, and I'm updating that data property of a chart.
Mm-hmm.
Is there some kind of a queuing with the data, or is this all random, gets into these various data elements and the graph gets updated in parallel with multiple data?
So you're talking about a use case where like there's multiple sources of data and you're fetching tables from different sources?
So my chart renders multiple data sources. That's me, right? It's not just one array of data.
I see. Well, the way I've done it, each chart visualizes one array of data. But if you want to combine data from different sources, you could have like another step that combines them together and then sets the output of the combination to the input to the visualization.
How about the performance? How much data you can process with this?
Yeah, the performance is limited by the browser and D3 and SVG. So it is limited. I mean, you can't visualize, I think, more than 10,000 points before the browser starts to slow down. But I'd like to address this limitation by doing data reduction on the server side. So actually, let me talk about that. That's a good transition. So yeah, this is from my PhD work, and I just kind of want to show you some highlights from the my PhD presentation. So there's this great paper called ImMens that sort of has in it a survey of big data reduction methods for visualization. And these are the popular ones. Filtering, so like if there's data for like 100 days, just take 1 day's worth, for example, or take only data from one particular region or one range of values, that's filtering. There's sampling, taking a random sample, like only take 100 random points of 1,000,000 and visualize those. And there's a few other ones. I don't want to really spend time on these, but the one I'm interested in most is binned aggregation. So what I mean by binned aggregation, like for example, if you have these points and you can impose a grid structure over the points. So this is one-dimensional binned aggregation. So in this example, these are the original data points, and you're aggregating them into bins that are specified by these little parts here. And so this bin has 2 points in it. This bin has 0 points. This bin has 4 points. So this is like a SQL group by operator. So one example of data expressed in terms of a result of binned aggregation is consider the population of each country. Here's the population of the 3 largest countries in the world, China, India, and the US. So this is, in a sense, binned aggregation, where the bins are the country boundaries that humans have drawn on the Earth, and then you're counting the number of people who are there in these bins. But binned aggregation can be done also in 2 dimensions. So let's say each of these points now has x and y coordinates, and you impose a 2-dimensional grid. You can count these, how many points are in each 2-dimensional bin. So in the data world, one example is taking the population of different countries at different points in time. So this is a 2-dimensional binned aggregation structure, and you could also do it in 3 dimensions. So imagine a data set with place, time, gender, and population, breaking down the population by gender. So imagine the data structure that this is producing. It's these multi-dimensional arrays, and the term for this is data cube, an OLAP cube. You could also do it in 4 dimensions, place, time, gender, age range, like 0 to 5, 5 to 10 years old, 10 to 15 years old, and population. So one cool project that someone else did was this interactive population pyramid. So this is one example of interactive visualizations of data. So the data itself on the client side is very small. This gets back to your question about the performance. So I wouldn't want to like download the data for each individual person on Earth, right? You aggregate it first and then bring the aggregated results down to the client. And then you can do really quick interaction. So this lets you navigate in time. Can you all see, by the way? So when you navigate in time, it has this cool animation that it does. And you can also sort of drill down to different regions.
But it's still working only with that sample, right?
It's working only with the, well, you say sample. It's a data cube that's been computed. So the data cube has years from 1950 to 2100.
You can't change the bins, I guess.
Yeah, you can't change the bins. Right, it's like pre-aggregated. Yeah, the data is stored in aggregated form on the server. But in cases where you have data that's too big to visualize directly, maybe you could compute this kind of aggregation on the fly on the server side, like in a Hadoop cluster, and then do this kind of interactive visualization in the client. That's sort of what I propose.
Down,
Yeah, but I think it's going to be kind of slow, because every time you change something, it's going to send another job that needs to execute and give you the results, which then you need to aggregate and present.
Yeah, but I mean, that's an feature anyways. If you've got a million points, there's nothing you can do without doing some sort of
100
aggregation.
million points in the browser. So, but your drill down is actually now making a request back to server, get the model.
Well, in this case, I think it's all loaded on the client. It's not doing any round trip. So the performance depends on how you sort of subdivide the data cube. So if you compute, like let's say for example, like you're saying it was going to be slow. Like if you compute the data cube for each year as you click the year, then it will be slow. But if you compute a data cube that has all years and give that whole chunk to the client, but then only show 1 year, and then give the interaction to change years, then it would all be resident on the client, so the interactions would be very fast. But in cases, yeah, I want to devise a system where you could choose, like, how much to aggregate before sending, and then maybe some interactions would trigger a round trip to the server and another Hadoop job or Spark thing to run.
There's a limit on how much data you can bring into the client.
Oh yeah, there's a limit on, yeah.
Browser memory limits.
Yeah, I mean, I'd like to keep the client-side data under 2 megabytes. I think it's reasonable to transfer a big JSON blob that's like up to around 2 megabytes. But beyond that, I think it's like...
I think visualization by nature, small amount visualization. You cannot really visualize billion things. So the trick is to aggregate things.
Yeah, you need to have some kind of abstraction where you can get the concept of the structure of the 2 million things without showing the actual 2 million dots.
You can drill down if you want.
Right, so drill down, like this data cube aggregation has hierarchical dimensions too, like potentially. So imagine.
I think you can also speed things up by caching or preemptively computing. Like if the guy is over here looking at this region, like you can preemptively compute things or a lot of tricks and
Forward-looking computation.
Right. That's true. So I want to show you some just examples of things that I've made. So here's an example with linked views where you have a scatter plot. So this is the iris data set where each point is a flower. So I'll just show you the demo. So it's a scatter plot and a bar chart, and when you select in the scatter plot, you define a subset of the points, and those are this is all happening on the client. It's being aggregated into the species, the bars, and that's being displayed as a bar chart. And then the subset that you select is also being displayed on the table below. So
using your the first slide you showed, what do you call that?
Model.js?
Model.js?
Yeah, so this is using Model.js. So each...
The propagation scheme.
Right, exactly, the propagation scheme. So each, in this thing, each visualization is a single model created by Model.js. So here's a little summary of the flow. Like when you change the brush, that updates this property called selected data in the scatterplot model, and then the main program instantiates the scatterplot, the bar chart, and the table, and then there's like a 3-line thing that just establishes the connection between them. It says like when the selected data changes, update the table and update the bar chart. So that's one example of linked views. Here's another example. So this is showing causes of death over time. So cardiovascular disease, cancer, respiratory diseases, each sort of area is one disease, and time is going from left to right. But this is a top-level view of a deep hierarchy of causes of death. And the linkage here, so I can sort of drill down into cancer. If I click on cancer, then now cancer becomes the root of this subtree, and then now I'm looking at all the different kinds of cancer. So you can see that like this green one, which is colon cancer, is going down, it looks like. And then I could drill down even further to like leukemia.
So how come mouse over is not showing what data you are on?
Oh, how come? Well, it could. I mean, that would be a good interaction.
That's interaction. Otherwise, you're going to look at those columns and colors and what
you're right.
cancer you are on.
That would be a cool thing to add. So yeah, conceivably, like as you hover over this, it could highlight over there and vice versa. Yeah, that's true. That's true. And another example, which is kind of the most advanced example so far, is the population data visualized with a timeline and a choropleth map. So each country in the map, you can hover over it, it tells you the name of the country and the population. And as you hover over it, it highlights in the line chart. So if I hover over China, I can see that this line is highlighted. So China is the largest country. And then if I hover over India, I can see that's the second largest country. So if I hover over a year in the line chart, it slices the data that's used as input to the map. So as I change this, it's changing, like this shows the data for 2000 on the map. Now I can go back to 1950. And if I click on like 1975 and go away, then it stays there. It stays on 1975. And also I can zoom in on the map, and then that filters the input that's used on the line chart. So now each line is a country that is visible within the map, and all the other ones that I can't see are not shown on the line chart. So here, like if I zoom into Rwanda, you can see that big dip right there in the 90s, between 1990 and 1995, and that's the Rwandan genocide. You can see it in the data. So these are some examples of linked views. But what I'm working on...
Those kind of a cause and effect, whether that particular leap in population was because of the particular event cause that happened in that time.
Yeah, so the linkage between what you see in the visualization and the concept. No, I haven't really thought about integrating that into this scheme, but conceivably it would be really cool to like go to this view and then add a little note like, oh, that's the Rwandan genocide.
Insight, right? Insight of the
Yeah, I noticed there's insights. In Chorus, there's an option to create an insight.
So there'll be a visual insight into why that.
So that would be cool to attach that insight to the visualization. Yeah, that's definitely a great idea. So, let's see how long. What I'm working on now is this whoa, visualization. This visualization editor thing. So here's the idea that there's a JSON configuration structure that is sort of coordinated with this runtime environment for these visualization plugins. So imagine A, B, and C are different visualizations, like a scatter plot, a line chart, and a bar chart, or a table, or whatever. So there's this JSON configuration over here. So this chunk here defines the layout in terms of nested boxes. So it says like, there's the editor, which is this JSON editor component, which is part of the page. And the layout is horizontal, so the children are placed from left to right. So the editor is on the left, and then on the right, there's a nested structure that is split vertically. So you have A on the top, and then another nested structure that goes horizontally, B and C on the bottom. And when I interact with this configuration, it will bubble through the changes to the layout. So I can change the size. And when I resize, you can see that the layout editor is a fixed number of pixels, while these other boxes are sized relative to one another. So I could change like the size of B, for example, down here. And so you could specify, if it's just a number, then it's assumed to be relative. But if you make it a string and put px on the end, then it acts as a number of pixels. And you can like change the color here. So this is using CodeMirror as the editor for the text. And there's a cool project called Inlet that gives you these color pickers and sliders for colors and numbers. So yeah, when you change the configuration, it updates the runtime components. And then when you change the runtime components, like I can drag this line, and it changes the line width property over here in the config. So it's like this bidirectional mapping. So, yeah, the configuration structure is like this. Each component has an alias, which is like a unique name in this environment. It has a string that determines which plugin is loaded, and then a state object, which is a mapping from properties to values in these loaded components. So this is kind of an architecture diagram of this whole thing. There's the configuration, and when that changes, it updates the components, the runtime components. And then whenever something changes in the runtime components, like as a result of maybe a user interaction or like some data being loaded, then that will propagate back to the JSON configuration. And each runtime component is constructed by a plugin. So a plugin is like a factory for these components. So like in the example, there was one plugin called the dummy visualization plugin, and that created 3 components. These are very overloaded words, but I just wanted to use something to distinguish between the plugin and the thing that's loaded, constructed.
So the editor is not for the plugin design, but
well, actually, the editor itself is a plugin.
No, like, so can you use the edit? Are you trying to make the editor so that you can, for instance, design a scatter plot yourself, or?
So the editor would be used. Well, first of all, like this JSON editor is kind of a temporary measure. Like the end user should not have to edit JSON, but it's like a temporary step. So this editor would allow you, if you had a data source and these visualization modules, it would allow you to sort of instantiate a scatter plot and say which data should be loaded into it, and what should be the x-axis and what should be the y-axis.
So you're assuming that there's already scatterplot module. You cannot design scatterplot module yourself.
Yeah, exactly. This editor is for using plugins that exist. Yeah, you'd have to write some code to make a plugin.
So this is essentially a layout manager.
Yes.
So you're using the other things to build the stuff you already showed earlier, and then plugging into A and B and C. And the
right.
Layout manager to dynamically show how my stuff is going to be dynamically displayed.
Yeah, exactly. So the other things I showed before, these linked views, conceivably, if each of those individual visualizations were made available as a plugin, then each of those linked views that I showed before could be created just by editing the configuration. So let me just go through the modules. So yeah, there's some foundational plugins that sort of the system needs to work. One is the layout, which does the nested boxes layout. The other one is the JSON editor and dummy visualization, and also links. So this is has not been implemented yet in this project, but it's been prototyped in another project. So the idea with links is that there's this links plugin can be configured to route interactions like output to input for visualizations. So like interactions like brushing in the scatter plot would create an output of those selected items, and then with using the links plugin, that output could be routed to input to another thing like the table, for example.
So when you were showing us the ones before where you did have the table underneath and one image,
right.
It's like here and it was here, is that not using links then, or is that a different?
It's not. It's not. That prototype is hard coded. I mean, but
this is to replace that aspect of it.
Exactly. But the path should be very straightforward to use this like runtime environment with those modules, because they're already they're already implemented as like these Model.js models. And that's basically what a plugin does. A plugin creates an instance of a Model.js model that you can configure. Yeah.
Maybe a little less abstract. Can you sort of bring this into how it might work in a typical dashboard environment where the user is going to configure which particular modules are on the screen?
Yeah, so that's a perfect lead-in to...
Just random.
Yeah.
So, so kind of as an abstract level, like ideally, there would be a user interface. Wait, I'm recording this, so I want to have myself in the picture. So ideally, there would be a user interface, right, where on the top, you can kind of select different visualizations as like icons. So there would be an icon for a scatter plot, an icon for a bar chart and a table, a heat map, box plot, parallel coordinates, choropleth map. These are the ones I want to target first, and then you could add more and more. And then you could sort of drag and drop them onto this nested box layout, kind of like how Eclipse does. Eclipse has this paned window manager sort of thing, so you can drag a Java file, and as you're hovering before you drop it, it'll show you how it's going to split. So I want to implement something like that for dragging and dropping instances of visualizations. And then once you click, once you have the visualization loaded, I want to have a little button where you can click like edit the settings for this visualization, and then it would pop up a user interface for selecting like the y-axis, the x-axis, things like that. What was that?
Data source that comes for the visualization. The data itself is predefined for that, or is the data is pre-selected? So all those 5 different icons, chart we have right now, you have to associate them with the data in the backend.
Right. So to associate it with the data, I mean, that's where it would kind of be sitting on top of Chorus. So Chorus has the data sets already and has a user interface. Oh, and one last thing. So in this imaginary ideal user interface, for the links, I want to be able to kind of turn the whole thing around and visualize each visualization as inputs and outputs, and then have the user like sort of connect wires from the output of one to the input of another in sort of the link editor view. So this is how I want the ideal user interface to be.
Workflow.
Let me ask another question.
Yeah.
Are you referring to our front page dashboards, and that could you do something like links on something that has nothing to do with these visualizations, but we already have a certain amount of dashboards that are on our front screen, and some of them are like tables, and some of them are pretty charts, but they don't have to be. Is there a way to hook up this sort of flexible layout with the dashboards that we already have in some way?
Yeah, I mean, I actually haven't seen what the dashboards look like. I haven't seen the dashboards. Maybe somebody could run me through that at some point. Because the only thing I've seen so far is in Chorus, this flow. So in Chorus right now, which is open source, for those who are not in Alpine. So here's what the flow looks like to make a visualization. So I've sort of, this is the page for a data set, a data table, a clickstream data table. So it shows you the columns in the table and if they're numeric or text. And then there's a little button here that says visualize. And then when you click on visualize, you get these options for configuring the visualization. So this is a step before seeing the visualization. You have to configure it first. So you have to select which category will be binned to create the bars. In this case, it's a bar chart. And then you click on Create Chart, this button here, and then you get this chart that pops up. And it's an image. And if you want to modify the parameters, you have to close it and then change it and then create it again. That's going to the flow. So let's say we close that one. We want to create a different visualization. We select from the top of this interface this little icon for a heat map. And then once you click on that, it gives you these different editing settings for the heat map. And then you click Create Chart, and it pops up the heat map. So that's what the flow looks like right now. And what I'm envisioning is something like this. This is a mock-up that I just copy and pasted images around. So imagine an interface where you could click these interactively and click which type is being shown, which type of chart, and then it would change instantly. And then change the x-axis and the y-axis while you're looking at the visualization, and then it would update right away, and filters also. And the idea for how to do this is this box where the visualization is could be this runtime environment with this JSON configuration, and then clicking these buttons could automatically edit the JSON configuration, and the system would propagate the updates through to the visualization. So this could be a first path to get these systems integrated on the way to the sort of incredible imaginary user interface. Yeah.
So you in the map example, you have this zoom in, zoom out.
Right.
So if you need to kind of follow up what he said is the data. So right now, all the stuff is the data already resides in the browser. So if we zoom in, the resolution will be different, right? You're using the average, and now you zoom in, you're supposed to.
Right.
So you need to get another round of calculation, go back, and then bring the data, and then display that data. So essentially, the data should have input streams, which is tied to not.
Right.
So how do you?
Let me pull up that.
Where that fit in?
Let me pull up the example. So you're talking about in this example. Let's say you wanted to zoom in on one particular country, and then that action of zooming in should trigger a query to the server to get more detailed data about that region. That's a great idea. I would love to work on that. Yeah, I haven't done anything that does that, but yeah, that's exactly what was needed. I mean, because you want to have an overview of the data set. That's maybe some pre-computed aggregation, and then you could zoom into one, in this case a country, but you could do it like, imagine a bar chart where each bar might have subcategories that you could kind of drill down into, like the causes of death. Actually, causes of death, that's kind of similar, but all the data in my example was residing on the client. But yeah, it could be done in such a way where once you drill down, it will make a round trip to the server. And
in some instances, you want to have there's so much data that you just can't fit into the
right. You can't. So you have to have these partial.
We need to also look at the other project, the Lightning project.
Oh yeah.
Jared Freeman.
Yeah, that's good work.
He's going to be here on March 26th, so we can ask him how he did it, because both similar ideas. And they're using Spark to make calculation and come back.
Yeah, or something like you want to change some query condition, for example.
Right.
You want to visualize in your TensorFlow, probably you can string the data.
Right.
Always what you show is the aggregate data. And then if a condition is changed, the aggregate data is going to be different.
Right.
Yeah, or something like online learning. What he shows is that you can circle, some sample and then do some training on top of it.
So the system itself is all asynchronous. So if there's a round trip to the server in there somewhere, it should all work just fine, like the way it's architected with this Model.js thing. But there will be like some intermediate component between the two visualizations that interfaces with the backend.
The other thing is that so all the examples so far is a two-dimensional. Do you have a three-dimensional?
No. No, I haven't. I mean, at some point I made a rotating globe, but like.
I guess most of the time users don't need because you can somehow present the same content in 2 dimensions.
Well, 3D has a different. I saw the reason I'm asking. I saw the Lightning project data rotation, and you can see the class rings in different dimensions. You actually rotate it. That's pretty cool.
Yeah, it's pretty cool.
I guess the plugin stuff is all JavaScript, right?
Right.
So do you think maybe we can add a plugin editor where you can I guess there might already be something like this, but if you type in D3 code, you can see what it looks like.
Oh yeah, oh yeah. I would love to.
Yeah.
This be a little snap.
If we can integrate with our stuff so that people can.
You can cut and paste data in there, it will show you.
Or basically you write an either D3 or 3D.
Yeah,
3.js,
you like it to save it.
Save as plugin.
Yeah.
And then it'll be part of your thing.
Exactly, exactly. So that's such a great idea that I just want to sort of talk about it a little bit. Like, so I've always been enamored with this thing called JSBin, where you can JSBin, where you can type in HTML and JavaScript, and every time the text changes, it'll rerun that code, and in this split screen kind of a way, and it's in the browser. So I think it would be so cool. Yeah, I think it would be so cool if you had exactly that thing, what you two were just describing, where you could pull up a text editor that maybe has like the basic boilerplate you need to make a plugin with D3, like that dummy visualization, and the user of the system, like the end user, not a programmer, could develop some D3 code, copy and paste, and every time they change the code, it could rerun against the data that they have loaded, and then click, save as plugin, and then type a plugin name, and then it would be available for all the other users. I think that would be totally cool to do, and reasonably straightforward. You just save the text in a database or to a file. Yeah.
Once you have a plugin, you can be part of your little panel. Say.
Right. And with regard to 3D, there's a great library called 3.js, which has very powerful 3D capabilities. I'm just picking a random example. I don't know what it's going to be. But it connects with WebGL. WebGL is like a JavaScript binding for OpenGL. And 3.js is a scene graph library on top of that in JavaScript. So, and people have done 3D visualizations. Oh, let me see if I could find the example. Yeah. This is whoa. There's some sound there. It's in 3D. Yeah.
We're kind of in 5D. 5D.
So, yeah. So there's 3D capability in the browser. Like it's, and the way I've set it up, like anything that can be put in a div can be one of these plugins. So yeah, conceivably you could interface with this library. Oh, here it is. Here's the one I was thinking about. This is a very cool visualization where each bar, it's like a 3D bar chart on the Earth, where I think it's showing population density or absolute population. I'm not sure.
Really density.
Yeah, I think, what is that?
That's the other thing.
It doesn't show you the mouse over anymore.
No, it's very simple. It's proof of concept, but there's San Francisco. Yeah, Mexico City. Maybe that's New York. And then in Africa, or South America, not Africa. Yeah.
To your earlier point about the programmers, do you know Brett Victor's work?
Yeah, Brett Victor. So actually, this thing Inlet that I'm just I'll let you finish, but this is a tie into Brett Victor. Like this is created by Ian Johnson. This is what I'm using as the color editor. And this was the original idea for this was from Brett Victor, but he didn't make his stuff open source. So this guy just took the concept and re-implemented it. But
the question I was going to ask, so given, let's say, visualization set up, I'm viewing it, have you built in the hooks to freeze that and basically export it as a snapshot, conceptual snapshot?
Right. So my idea is that JSON configuration itself can be exported and written to a file or into a database and then loaded up later to recreate the exact same state. And it's not just saving an image, it's saving the whole state of the visualizations, including like whatever you clicked on or zoomed into as part of the state. So yeah, that's actually one big piece of what I like to do with this. Yeah, be able to save the visualization and then have other people load up the visualization not as an image but as this interactive thing, and then create derivative works. So you'd have this sort of graph of like derivative works with the visualizations.
Another thing we should think about is allow people to annotate charts and graphs.
Mm-hmm.
So while we are looking at it, to see something like we do inside into our activity stream, we actually do annotation on the graphic itself and then save it. So that somebody else looking at the chart later can see who made the observation or insight on the chart itself.
Yeah, it's a really cool idea. Yeah, it could be hard, but that's a great idea.
I might take the activity stream and then opening the chart and see what happened where it's like disconnect.
Yeah.
Connect the observation inside. Somehow indicate visually.
Right.
Where in the data.
So I guess more fundamentally, the visualization plugin should be able to talk to the server.
Right.
Also, because it's big data, you want to say, I want to see this portion of data. But
right, the filtering. Yeah, there will have to be some plugin that interfaces with the backend. Yeah, and there has to be some corresponding services that do the filtering or the sampling or the aggregation.
So is your library only working with D3 so far, or so can you integrate it with the other libraries? You mentioned 3.js. Any other plugin or whatever? I don't know. I'm not familiar with the JavaScript.
So most of what I've done is D3, but this is an early prototype of this system. Oops. I want to run it. Try it out. So this is actually a leaflet map. So this is using leaflet over here, and it's making a request to a server to get the image tiles for the map. So this is one example of leaflet next to D3, but I have not tried it with anything else. But you could. I mean, oh, and the JSON editor, like this is a code mirror editor, and it is a plugin also. So text editor, D3, leaflet. You could make something with 3.js, but I haven't done it.
I was thinking that people who already done basically leveraging other graph already on different
Right.
They said, well, I want to use your framework, but I don't want to recreate this thing, so I can put it in.
PHP has a huge library of charts and graphs.
Well, they have a huge gallery of examples, each of which is hard-coded to a data set. That's right. So a lot of those, I want to make plugins. Actually, yeah, let me... I did want to talk about this one particular piece of this. So these are some visualizations that I want to make into plugins. And each of these have D3 examples. And using this Model.js style, there's like a straightforward path from going from the example to a reusable component. And so on the right, each visualization is described in terms of its data cube structure. It can be thought about as taking as input a data cube, like pre-aggregated data. So a bar chart is one dimension, one measure. And a pie chart is the same structure as a bar chart, really. It's just visualized differently. A scatter plot would be one dimension and two measures. So a dimension is like a categorical thing, specifying individual items. And a measure is a quantitative property. Parallel coordinates shows one dimension and n measures, like depending on how many parallel coordinates you have. I'll make it bigger. Choropleth map shows one dimension, which has to be the space dimension, or geographic dimension, and one measure. And then there are also hierarchical visualizations, like the sunburst. Like if you have any tree structure data where each node has a value associated. I don't know if you guys work with that kind of data, but yeah. Oh yeah, random forest. So there's a sunburst and an icicle visualizations for hierarchical structures, and then tree map, that's another hierarchical visualization, and then stream graph, which is kind of like a stacked area chart, but and usually it shows things varying over time. But it shows like how, yeah, kind of like a multi-dimensional time series.
That's we have something, I think, based on this package.
Yes, I noticed in Alpine there is one of these things. So, yeah, these are what I would like to make into plugins. So far, the scatterplot and the bar chart are pretty much almost already plugins, but the other ones will all take some work.
So I think from machine learning's point of view, one really popular visualization for classification is the hyperplane. Like, where is the hyperplane? That's
oh yeah.
Things, but I don't know how useful it would be for multidimensional.
I've seen some really cool visualizations of like support vector machines. Something like this.
They're for high dimensional.
Yeah, so that's the problem. Like, it's useful for demonstrating the idea, but
I think it's,
yeah,
because people use more than 2 dimensions.
right.
yeah, it's most I think you can do 3 dimension.
Yeah.
Yeah.
But maybe if you can change the dimension values and then maybe.
So I would like to go in that direction too, of taking the output from various machine learning algorithms and overlaying that on top of the visualization somehow. I don't know how exactly, but that would be cool. Definitely.
Well, you don't necessarily have to show the hyperplane, but just if it's classified as 0, then the color.
Right, you could use color. You could use color, right, to display the categories.
If it's not linear, then it's going to have very complex structure.
Mm-hmm. Yep, and I was thinking maybe interactions in the visualizations could cause round trips to the server that maybe tweak some parameters of some machine learning algorithms, and then that could be a way to tweak your models. I mean, I don't know. I really don't know machine learning that well, so like, but it'll come. So that's what I've got. So.
Very cool.
Thank you.